You're finally ready to use a real scroll view. Similar to a container view or a stack view, a scroll view is a container for content. You add a scroll view to the view hierarchy, like you would with any other view, and then fill it up with subviews. The main purpose of a scroll view is to add more content than what can fit on screen at one time. Table views and collection views are some examples you already know. Scroll views are also great for viewing large images that you want to scroll around in both directions, a horizontal slider of icons, or a tall view filled with options. Scroll views are an interesting case when considering how their size is determined. Like other types of views, they have a size. But they also have a content size. The size of a scroll view describes how much screen real estate it takes up. The content size, however, describes the size of the scroll view's subviews. You can also think of this as the scrollable area. If that content size is larger than the scroll view size, then you're able to scroll.
There are a few ways to get that content size. If you correctly set up auto layout constraints, it'll be set for you. You can also manually set the content size, and we'll do just that in the upcoming demo. The app we're going to work on in this video will allow you to scroll around an image that's much larger than the screen. In our case, we'll use the image view size as the content size. If the image size is larger than the scroll view, we'll be able to scroll.
To get you started, we put together a mostly empty starter project. There's an image here from a zombie run that Ray did some years ago. It's a pretty large image, too large to display the whole thing on an iPhone screen at full size. We're going to use a scroll view to let us scroll around and see the entire image.
To start, open main.storyboard, open up the object library, and drag a scroll view onto the view controller. Drag the edges of the scroll view out so it fills the entire screen. Then, with the scroll view still selected, head to the size inspector and set up auto resizing so that it will stretch to fill up the screen and be pinned to all four sides.
Now we need an image view to hold the picture of Zombie Ray. Drag an image view from your object library right on top of the scroll view. Make sure it's a subview and not a sibling of the scroll view. Then, just like you did with the scroll view, drag the edges of the image view out to fill up the entire screen. Then in the Attributes Inspector, set the Zombies image, and for the Content mode, you want the image to be in the top left. At this point, you probably noticed we haven't constrained anything with auto layout, and you can see over here we have some layout errors.
For the next few videos, we're not going to be using auto layout. It adds some complexity that we'll tackle later in this part. So for now, we'll live dangerously and disable it. Select the view controller and go to the File Inspector. Then uncheck Use Auto Layout. Xcode will ask if we really actually want to disable auto layout in size classes, and for now, yes, we do. You can try to build and run now, but you won't be able to scroll yet.
That's because the content size of the scroll view is the size of the device as opposed to the size of the image. You can only scroll when the content size is larger than the actual scroll view. In the future, auto layout will provide the content size for you, but there are a few alternative ways to resolve this. One way is to pass in the size by way of an attribute. Select the scroll view and then the Identity Inspector. In the user-defined runtime attributes, press the plus key to add a new key. The key name is content size. The type is size, and the value is 2592, 1936. Now, build and run.
And we've got scrolling. If you want the content of your scroll view to start all the way at the top of the view controller and underneath the status bar here, you can set that in Interface Builder. Select the scroll view, and in the Size Inspector under Content Insets, change Adjustment to Never. Build and run one more time to see that scrolling image take up the entire screen.
What we've done here is pretty inflexible. The content size is hard-coded in Interface Builder, so if we were to change the image, the content size would stay the same.
There are ways to programmatically set the content size, and that's the topic of your upcoming challenge.
In the last video, we added a scroll view to an app and set its content size via an attribute in Interface Builder. The problem is that attribute is hard-coded. If you changed images, the content size might be too large, too small, or the wrong aspect ratio. In this challenge, you'll need to set the content size based on the size of the image, whatever it may be. Here's a quick to-do list to help you out. You'll need to delete that attribute, create an outlet to the image view, and set the scroll view's content size property based on the image view's image. Pause the video, give it a try, and then come back here to see how Katie fared. Welcome back! If you tried to run the starter project, you probably noticed that the zombie image has been replaced with this giant vampire toucan image. It's not the same size or aspect ratio as the zombie image, so if you scroll, you'll see that you have all this white space on the right, and you can't scroll all the way to see the bottom of the tail feathers.
Your challenge was to fix that. So let's see how your solution compares to mine. The first thing I need to do is delete the hard-coded attribute. Open main.storyboard, select the scroll view, and then select the content size attribute. And click the minus button to delete it. Next, I need to create outlets to both the scroll view and the image view. So open up the assistant editor and create the outlet by control dragging from the scroll view. Then do the same for the image view. That's all I need to do in the storyboard, so I'll close the assistant editor and then select viewcontroller.swift. Now everything is in place to set the content size. A good place to handle that is in viewDidLoad. First, access the scroll view's content size property and set it to be the image view's image's size. The image property of an image view is an optional, but in this tiny app, we know we have one, so I just forced unwrapped it here. And that's it! We can build and run.
And now, with the content size pulled directly from the image, the scroll view is working as expected. There's no white space on the right, and you can scroll all the way down to see the bottom of the tail feathers.
We can scroll around in our image, but it would be nice to zoom in and out, too. In order to do any kind of zooming, you need to implement a scroll view delegate protocol. As the user interacts with the scroll view, you can receive callbacks by setting an object to act as the scroll view's delegate via the UI scroll view delegate protocol. This protocol contains a bunch of handy methods. Scroll view did scroll is called whenever the content offset changes. Scroll view did end dragging is called when the user stops dragging on the scroll view, and so on. There are several of these delegate methods related to zooming. You can be notified when the zoom changes with scroll view did zoom, before a zoom with scroll view will begin zooming, or after a zoom with scroll view did end zooming. The method we're after, though, is view for zooming in scroll view, which just sets the view to be zoomed. All you need to do is return the view that you want to zoom from this method. If there are multiple subviews, you can group them in a container view or stack view, and then return that parent view. When you want to implement zooming, you'll also need to set the minimum, maximum, and default zoom scale. Let's give all of that a try now in our image scroller app.
Time to add some zooming to this app. We can start by deleting this line that sets the content size. Instead, we'll set the image view's frame size to be the size of the image itself.
This is another way to establish the content size of a scroll view. A UI scroll view, somewhat like the stack view, will inherit the size of its subviews. In this case, that's the image view. If you run the app now, the image frame will be the size of the actual image. But that's not exactly what we want. We want to be able to zoom. To do that, we need to implement one of the delegate methods we talked about. We're going to set viewController as the delegate, so we should start by creating an extension of viewController and have it adopt the UI scroll view delegate protocol. We need to tell the delegate what views to zoom on, so the method we want to implement here is view for zooming. It should autocomplete for you. And we just need to return the view that we want to zoom, which is our image view. The last step here back in viewDidLoad is to set viewController as the scroll view's delegate.
Now we're ready to set some properties to customize the zooming experience. Start with the minimum zoom scale and set it to 0.1. That's as small as we ever want the image to be. Then set the maximum zoom scale to 3. And finally, set the zoom scale property to 1.0. That's the starting scale for the image, and using 1 sets it as its natural size. Build and run to test it out.
Now we can zoom out and in on this wacky bird. Notice how the size of the scroll view is updating as we zoom. We don't ever have tons of white space on the side. Also note that when we rotate the device, the image maintains the set zoom level.
It might be nice if the image fit the space better after rotation. Our goal is to zoom the image to fill up the scroll view in one axis. We can do that by comparing the size of the scroll view and the image, and then setting the zoom scale based on whether the image is closer in size vertically or horizontally. In this example, the image is 50 by 50 and the scroll view is 80 by 100. To find out how much the image would need to scale up to fill the scroll view in either direction, divide the size of the scroll view by the size of the image. Here we can see if we scale up the image by 1.6, it will still fit within the scroll view. But if we scale the image up by 2, it will exceed the size of the scroll view. So we'll take the smaller of those two values, in this case 1.6, and set that value to both the minimum zoom scale and zoom scale when the device rotates. Create a new method for that and name it set zoom parameters. First, we need the actual image size, and we can get it from the bounds property. We're going to set the scale differently depending on how the image size compares to the scroll view size. First, calculate the width scale. And then do the same for height. Now we can find the smaller of those two results using the min function.
That will be our new minimum scale and starting zoom scale. So go ahead and cut and paste all of the zoom properties from ViewDidLoad into our new method. Set the minimum scale and zoom scale to min scale, and leave the maximum zoom scale alone. Now, when the user starts up the app, the image is going to fit exactly within the dimensions of the device. To make that happen, we're going to call this function from ViewDidLoad, passing in the scroll view's bounds. We also want this to happen during a rotation event. After a rotation, view will layout subviews is called, so we can override that to call our method at the appropriate time. Now let's build and run.
Now Katie's Vampire Toucan fits exactly within the width of the device. Zooming still works, and when we rotate the device, the image exactly fits vertically within the space.
But everything is always scrunched up to the upper left. In the next exercise, we'll show you how to center the content.